For my final project, I built a remote-controlled car with a joystick to control the motion and an infrared proximity sensor to display when there's an object less than 2 inches in front of the car. The actuation is the 2 DC motors being controlled. And for my processing, I've created a car dashboard which does not display the actual speed of the car because I don't have an accurate way to measure that, and instead displays what I believe a rough estimate of flooring the gas pedal of a car would be, so that when I drive forward, it increases drastically at first and slows down until it reaches the maximum value. For my Arduino transmitter code, I first have to open the RF module library and include it, and then I read the values from the joystick and convert them into a PWM signal, which I then determine a turn signal and a speed signal so that I can send more power to one motor to turn in a certain direction. At the end, I have a string to send to processing, and I have to create one variable with a combination of the 2 motor variables to send through my radio.write so that I can read one value at the end, which I then, using the same libraries, read and convert back to a PWM signal, which I use to determine whether to go forward or backward, and then if there's an obstacle, I send a separate signal to reverse away from it. In my processing code, I use the method that we used in previous labs with the code that was given to us to import the values from the Arduino code, and I set up the car dashboard using a variety of different arcs, lines, and text. When I imported the code, I mapped it to an RPM and velocity value in radians so that when I put it into the line later on, it would create the image of the speedometer dial rotating about the center. Now it's time to have an RC car drag race. The finish line is the recycling bin. Parallel parking challenge.